Alrighty, so I talked to the owner and he's good for us to move forward with the trim pot concept. So we're going to go ahead and solder this end into this eyelet. This end we will connect to a resistor, which will go right here. I've got a 10K carbon film that'll go right there. And then this end back here will be the wire that is connected to the far lug of the, I believe this is the intensity pot, which is what the bias flows through, because as you adjust the bias, it's one of these things what's kind of quirky about the Fender Princetons is that it affects the tremolo. So you know, there's kind of a limited range you can bias these amps at while still maintaining a full tremolo sound. So anyways, let's go ahead and prep this. So I've got this lead I'm going to leave long. This one I'm going to bend over to basically J-hook a resistor. And then this one I've already J-hooked to accept the wire. So let's go ahead and do that real quick. Basically, I just don't want it completely floating in the air, even though it doesn't look as, you know, perfect, maybe being slightly off to the side. It's supported by the backer board. So when you're using your screwdriver and you're pushing down, you're not really putting stress on any of the components because the backside is actually touching this backer board, if you can see that or not. And it's not touching the metal screw. The metal screw is still accessible, so that's not an issue. So I think that'll be good, like so. Let's add some solder there. Then we'll hit this side one more time just to make sure it's really solid. All right, perfect. So you can see we've got it all done here. The bias, it's supported, and yeah, everything looks great. So now I think we're good to go to plug it in and do a first little test to make sure we're actually getting negative voltage off of this. So make sure all that's working correctly. We're not going to plug any tubes into it. I think we're just going to do a quick test to make sure there's no catastrophic issues and make sure we're getting negative voltage, and then we will start figuring stuff out from there. So awesome, we're making good progress. Cool, so we've got the amplifier hooked up to the current limiter, which is then hooked up to my Variac off screen. We've got a speaker connected to it, the original, and we've got the multimeter connected to the adjustable bias pot we added in on the middle wiper section so that we should be able to see if there's any negative voltage coming through. So let's go ahead and give it a little bit of voltage. We'll turn it on first and then give it a little bit of voltage here. Let's give it all the way up to 120, and there's no light here, which is good. There's no excess current draw, which means there's no dead shorts or anything. So now at 120 volts, and we're looking at negative 32 volts DC. Let's go ahead and grab our little screwdriver here, and then carefully adjust this, and we should see it change. So one extreme we see about negative 10 volts, and then the other extreme we saw about negative 37 or so. So that's perfect. Let me check the schematic real quick. I'm not sure. It should tell me what voltage it is expecting to see, but this amplifier was also made for 117 volts. So we got a bit more coming from the wall now. And the other component to this too is the owner wants he wants to experiment with rectifier tubes in this. So he provided probably 4 or 5, I think, different rectifier tubes, if I remember correctly, to play around with. So we'll have to kind of see what that looks like. Looks like we are slowly climbing, which is interesting. It's not super stable. I guess it is kind of stabilizing. No, it's still climbing. That's interesting. I guess it doesn't completely surprise me, but it is something to note. But overall, I'm happy. There's no dead short. Everything looks good. The bias adjustment is looking good. So let me check the schematic, look around a little bit more, and then we'll come back. All right, so looking at the layout here for the Princeton Reverb B1270 is showing the negative voltage should be about negative 34 volts DC, and this is at 117 volts from the wall. So we're looking at a max or the lowest amount there at negative, it keeps climbing. So negative, looks like it's going to be negative 46 here in a second. Yep. So it is steadily climbing, but we definitely have plenty of range to cover anywhere that the bias needs to go. So let's continue looking around a little bit, and then if we feel comfortable, then we might add some tubes and just start seeing what that looks like. So we've got the rectifier tube plugged in now, and we're still plugged in the current limiter and the variac at 120 volts. So let's see what happens here. All right, I can see the heaters of the filaments of the rectifier tube have lit, which is good. So we should be getting some more voltage everywhere. And let's just confirm the bias voltage real quick. So negative 47. And then let's check some more voltage areas. So here we should be getting quite a lot of voltage in the 400 range. Yep, so we're getting almost 500 volts there. So we're seeing some leaky voltage here on the board. Up to about 0.1415 there, and right here is where the bias is connected. I'm not sure if I can reach that terminal. Let me grab the bias, the other type of probe for my multimeter. So this wire right here, this white wire, which is going in between these two resistors here, this is the bias supply. And so right here we should be getting that negative 47 roughly volts. That's correct. And then next to it, there's another eyelet here. So between those, let's see if there's any leaky voltage in between. Not much, actually. Less than I was expecting, to be honest. But this is a jump off point where, again, there's more high voltage, which we'll see right there. All right, so I threw in a pair of my own JJ6V6s in just to do a test. I've still got the rectifier in, obviously. And I just wanted to see kind of what the bias range was and whether the bias control kept shifting drastically as far as the value it's reading. As you can see, it's pretty stable. It's not going up or down, just kind of going between negative 33.53 / 0.52. So it's not drifting up like it was before. So just something with no tubes in it causing that, but with the power tubes and rectifier in there, it seems to be stable, which is good. And yeah, I set it to roughly negative 34 volts, which is what's on the schematic. And we're at 119, 120 volts from the wall right now. And I've got my bias probe plugged in. I'm not sure if you can be able to see those readings or not. They're very faint. But the plate voltage is 366 volts roughly, and the plate current is roughly 26. So when we put that into our Robinette bias calculator, that puts us at roughly 9.5 watts plate dissipation, which is just about 70% with those JJ tubes, which is right on the money, kind of exactly where we want it to be, more or less. So that's great. If I move it, see for you guys to be counterclockwise, the bias gets cooler and we can get it down to like 30%. And then obviously we go up, we have a lot more range to cook the tubes, which we don't want to do. So this is kind of perfect. And yeah, everything's looking great. So I think we're going to go ahead and put in some preamp tubes in the amplifier, and then we'll disconnect the current limiter from the signal chain, and we'll put in his power tubes in here as well, and then just see how it sounds, make sure there's no catastrophic issues or anything that jumps out as a major problem. And I'm sure, again, there's going to be some leaky voltage, so it's probably some of the pots are going to be a bit scratchy and whatnot. But we'll tackle that later. I just kind of want to make sure we have a good baseline. And so far the bias looks solid, so obviously we'll recheck it with different power tubes, and then when we change the rectifier, we're going to have to recheck it again, but we're just taking baby steps here. But everything I'm seeing is looking good, so really happy. Let's go ahead, turn it off, and do all of that. So we've got all of the original tubes that came with the amplifier back in it. The power tubes are replacements, but the all the preamp tubes are what came from this amplifier from the factory as far as I can tell. And we still have the stock value rectifier tube in it. So we're going to go ahead and fire it up, check the bias as is, and then I've got a guitar plugged in, so we can just do a quick little test to make sure everything is sounding okay. And then we will switch out the rectifier tube, see what that does to the voltages and the bias, and then yeah, go from there. So let's go and fire it on. I see all of the filaments on, except for it looks like the 1287 might not be lighting for some reason. Yeah, it looks like that 1287 is dead. Possibly. I'm not seeing it. It doesn't look like it's lit at all. But we can still check the bias. Regardless, that doesn't matter. Let's pull up our calculator real quick. And that puts us right at 79%. So let's cool that down just a little bit. So let's check that now. So we're now at about 424 volts DC for plate voltage, and then plate current. Looks like we're hovering around 22. That puts us at 66.6%, which is just about right on the money where I'd want to be. So that's perfect. Now let's go ahead and strum the guitar real quick, see if we get any noise. And if we don't, a obvious possible issue is that 1287 that looks like it's possibly not lighting up. All right, let's see if we get any output. Turn the guitar up. Turn it up a little bit. So a lot of scratchiness on this pot. So definitely there's going to be some DC on the pot. Can't tell if that's the bass or the treble one on this. That would be the bass knob. Treble knob seems okay. Volume pot seems okay. Quite a lot on, I think that's the reverb pot. And then the trem, this one's got some, this one has none. So yep, definitely some leaky voltage to deal with, but that's okay. We'll tackle that as we go. Yeah, I mean, honestly, man, it sounds great. I don't know on these ones if you need to have a foot switch for the trem to work. So let's just see if I turn it up. Nope, it works. Works great. Awesome, that sounds killer. Man, this is going to be a rad amp when it's done. Okay, brilliant. We're in a great spot. So let's go ahead and turn it off and let it cool down, and then we will swap the rectifier tube. He was wanting me to try out this Sovtech 5, I don't know if you can even see that, Sovtech 5F4G. And yeah, so we'll give that a shot. I know there are some, you know, the rectifier is going to change the voltage in the amp. It's going to do a bunch of stuff. And but the owner had done a bunch of research and told me that this one should be totally fine. So we'll give this a shot. I've never tried swapping rectifiers around an amplifier outside of what they are originally spec'd for from the factory. So this will be kind of interesting. I believe he said it should give less volume and more sag, if I remember correctly, versus the, gosh, I think it's a 5U4. I think it's a 5U4 that's stock in these. Anyways, let's go ahead and swap that over and yeah, just make sure everything works. And we probably will have to rebias it, but we'll get there. All right, we've got the 5V4 rectifier plugged in. So let's go ahead and fire it up and see if that changes the voltage at all for the bias. So for reference, with the old rectifier, we were at 424 volts DC for the plate to cathode voltage. And then for the plate current, we were at 22. Now, I don't know if changing rectifier would change this at all, actually. Like I said, I've never tested this before. So it's a first for me, but we will see. So it does look like our plate voltage did go up a little bit. So we were at 424 before, now we're at between 428 and 430, so we'll say 429. And then the plate current is 22, 23, 24, so we'll go 23. And that puts us at 70%. So we went from basically 66% plate dissipation to 70%, which is totally fine, and we can always cool it. There's more room on the bias pot there, but I think 70% is fine. So let's go ahead and grab the guitar and see how it sounds, if different at all. I'm sure it will, you know, in an environment where I can really crank it and play it, but let's just hear it real quick and make sure everything is sounding okay. Awesome. Yeah, to me, it does sound a bit quieter. It's hard to tell. I mean, it's not that loud of an amp, honestly. I've got it on roughly, what, 7? Guitar all the way up here. Finger picking, not smacking it, but still. If I were to do that with my Vibrolux or Pro Reverb or the AC30, it would be shockingly loud, so and punchy. But hey, that's the great thing about a small amp. So awesome. I'm feeling great about it. It is dead silent. I mean, I hear basically nothing. Granted, the cabinet is pretty far from me right now, but yeah, I hear basically nothing. So awesome. I'm really stoked. So next steps, we will figure out all of the leaky voltage areas. We will do just like we did for the spots where we installed the bypass caps. We'll let the soldering iron kind of purify around the eyelets, any of the wax and impurities there. We'll, you know, scrape off the wax and just try and make sure we're, you know, not leaking too much voltage anywhere and causing that scratchiness. I'm not sure if you can hear that. It's pretty slight. The bass pot's got it pretty significantly though. So yeah, so we've got, let's see, that's fine. Bass pot was bad. So it's bass pot, reverb pot, and the intensity pot. Those three are showing issues. I did already spray some deoxit in it a while back, so I don't think the pots themselves are too dirty. Maybe they still are, but I'm sure primarily it is leaky voltage. But anyways, we're gonna go ahead and end there for tonight. I'm stoked. Can't wait for the owner to see this. And yeah, we're continuing on. So after we get rid of any leaky voltage, make sure, you know, there's no scratchiness in any of the pots, we will be looking at installing a mids pot, which is, I've got it somewhere else, but yeah, the owner provided the parts for that as well. I can't remember, to be honest, where he wanted to install it. It might have been to replace the ground switch and do it right here. Yeah, I can't remember exactly, so I'll have to look back at the notes. It's been a minute, but yeah, so we'll be doing that next. And that'll be another first for me. I've never done that before, but it's pretty straightforward. And I'm really curious how that changes the sound of a Princeton, because I think a stock Princeton is just such a great sounding amp. So I'm curious to hear how that sounds. So anyways, we'll end there. Thanks so much for watching, guys. Until next time. Cool, so I've gone ahead and touched the soldering iron on, I believe, every eyelet. I don't think I missed any. And yeah, just basically to, like I said before, kind of purify the surrounding area. Hopefully that will eliminate any of the leaky voltage we saw, which was causing some scratchy pots here. And yeah, just kind of add a touch of fresh solder so everything looks nice and shiny. I did try and remove some of the wax. Mainly what I focused on is just trying to, remove the wax between different eyelets that are not connected. So just kind of trying to make sure that there's not really any wax between there. That could be, a conduit for the electricity to move between, so you get some of that leaky voltage. Now this board is extremely waxy. It just got giant piles of wax everywhere. To remove all the wax on this board would be an insane project. It would take so much time. You'd have to literally, remove every component, douse it in isopropyl, scrub it. It would just be a nightmare and take a ton of time and cost an exorbitant amount of money. So that's just the nature of these 70s Fenders, is they just have super waxy boards, and it is what it is. They're not the prettiest to look at, but once they're up and running and there's no leaky voltage, they're pretty solid. So not that big of a deal. So now that I've done that, I'm going to go ahead, fire it up, and then we will see if we're able to detect any leaky voltage. And yeah, and then we'll go from there. So we'll be checking all of the coupling caps here. And yeah, so let's go do that now. All right, as far as I can tell, it seems like there's not really any voltage anywhere. Let me pull out the little probe from my multimeter here and just test around the board, see what we're getting. So I'm not sure if you can be able to see this or not. Maybe if I put it over here, you guys will see it. So we got high voltage right here, and the board right next to it, a little bit here. So here we have the bias, so there's some leaky voltage here, so we'll probably want to clean this area out a little bit. Let's see over here. So the board, we're getting 0.1 volt here, so it's quite a lot. It's interesting because there's not really any wax here. We do have the high voltage there and there. How about right here? Quite a lot. Wow, 0.3 volts right here. Clean, this is 0.6 of a volt. All right, let's put some preamp tubes in it, and let's see if we're getting a lot of crackle still in the pots. And then from there, we'll turn it off. We'll discharge the caps, and then we will try and carefully apply isopropyl in the areas between the eyelets, just to kind of clean it out a little bit. All right, so we're still getting pretty significant pops on the reverb. Looks like we're still getting a little bit on the intensity pot. And the reverb is quite extreme, the pops. Let's check the reverb real quick. One more time here. So on the reverb knob, so on the reverb pot, we are getting 0.019 volts on the center lug, and the same on that. So on the other lug. So let's go ahead and trace those. And they're terminating here. So we should be getting about the same, and we are here. And then the white, the middle lug is going right here. And we're getting the same. Yep, so we can see that these two have DC where they shouldn't. So let's see this here. You can see here we've got high voltage, 176 volts, goes across this cap here, and this should be removing all of the DC. So there's a small chance that this cap is actually bad and it's leaking, but more likely, if we go to the side of it, yeah, so we can see right next to the eyelet, we got 0.2 of a volt. This side less so. So definitely we need to do some cleaning here. Checking the tube sockets now in the tube, see if they're microphonic. And they're not. They seem solid. Tight fits too. Like this amp is definitely seen very little use. All right, so we've hit this area pretty good with isopropyl, and it feels pretty good to the touch. Got a lot of wax off, obviously. So I think what we'll do is fire it up and see if we're still getting a leaky voltage. So I focused on this area because this green wire and this white wire are the two that are going to the reverb pot here, and they were showing some DC on the pot there. So there's some leakage happening here, and yeah, we want to make sure there's not any of that. So there is a chance too that this cap, I mean, small chance, but there is a chance that this cap is just leaking as well. And yeah, I'm not going to completely rule it out, but let's start here, see what that looks like. And if there still is some, then maybe we'll remove these three components here, deep clean this area, and try again, and then go from there. So we'll go ahead and fire it up real quick. Grab the multimeter. Apologize if you hear my jacket moving around. It's kind of like a windbreaker. It's I think it's 64 degrees in my garage right now, so it's quite cold this time of year. It gets very, very chilly, so just trying to survive here. All right, let's go ahead and turn it on. We are connected to a speaker, so let's see if we got any change. Yep, we're still getting leaky voltage here. Still getting leaky voltage here. Still. Wow. Wow. I am actually really surprised by that, to be honest. Ton of noise coming from the amp all of a sudden. Not related to the volume knob. And now it's gone. Weird. Okay. You know, I think you know, there's a chance these resistors right here, these what are they, 100K, 1 watts. Those are pretty famous for going out and causing issues like, you know, pops, crackles, whatever. So those are pretty common to replace. I'm not 100% convinced that's an issue yet, but something to be aware of. But definitely something after the volume controls, as the amp warms up, it was like this making this kind of crackly, popping, hum, buzz noise. I'll see if I can record on my phone. It's always hard to describe those noises, but I'll try and record on my phone and then show you guys so you can hear what that sounds like. Surprise, because on the board here, again, just to show, getting 0.15 volts here, 0.2 volts here, less here, 0.1 volt there, 0.1 volt here. And I don't know if you can see on the camera. Let me zoom in a little bit. So hopefully you can see, it's very clear that I've wiped off a ton of wax. And I think you guys saw, if I recorded it, me adding isopropyl here, multiple layers. In fact, you can see the end of the Q-tips here, getting all that grime off. Focus it. So these were doused in isopropyl and then scrubbed. So yeah, I'm not really sure. I guess I can just keep doing it. But to me, that kind of rules out the issue being this cap, because there's just so much. Like, look at this, 0.25 volts here, 1.5 volts. Sorry, 0.15. So yeah, so we are at 0.019 before, and we'll see the same out here at the eyelets that are connected to that pot. These green wires again, green and white. All right, so this is going to be a bit more of a pain than I initially anticipated. The amp sounds good, but yeah, we're just gonna have that giant nasty pop because of that voltage. So bummer. All right, I think I'm gonna have to do some research actually to see the best method to get this out, because I put a lot of isopropyl here, and I would have expected more after doing all of that. So I think we'll probably end here. Yeah, it's already pretty late. So yeah, I think we'll end here, and then yeah, we'll go from there. Maybe this will be the end of this video, or we'll just continue on in a moment. So either way, thanks for watching, and see you in a bit. Well, the plot continues to thicken. I just did a ton more isopropyl here, scrubbed it really, really good, and got all of the wax off here. There's no wax left here. And yeah, you'll see, look at, we're now getting more DC volts on the board here than we were before I did this. So look at this, we're getting almost 0.3 volts here. Before we were getting quite a bit less. Over 0.3 volts, 0.4 now. Crazy. We're getting 1 volt here. That's insane. 4 volts. I'm extremely confused. How are we getting 4 volts here? So this end is high voltage, we know that. So we're getting 4 volts here on the board. And that's after layers and layers of isopropyl and scrubbing off. 0.1 here. I'm lost. I'm not really sure, to be honest. The only thing I can think of is if I use a heat gun and more isopropyl and try and extract it out of the board that way. So I actually ordered a heat gun already for a different reason. It's going to be here in like a week or something. So this is probably going to be delayed. But yeah, I'm not really sure what to do other than I can remove all those components and clean it with the components out. But to be honest, I'm still getting, you guys saw right here, I'm still getting voltage here. In some cases, you know, almost, was it 4 volts right here? And that's after there's no components in the way. And that's just a blank spot on the board, and it's covered in isopropyl as well as scrubbing it. So I'm not sure how much that's really going to help. I think I probably need maybe some heat or something to help extract it. And again, also worth reminding you that I already hit every eyelet with a soldering iron and let it sit on there for a second to really get all of the wax and kind of area immediately around the eyelets clean, scrub them out. So yeah, very, very, very leaky board. And well, that's what you get with the 70s Fenders. That's just what you get with them. So that's definitely why, you know, I definitely recommend the blackface era. That, a bunch of reasons, but really just the build quality is so much higher and no wax to deal with. They will still get leaky boards, but they're much easier to deal with, at least in my limited experience, because yeah, I've never seen that happen before, like what I'm seeing with this. So anyways, we're gonna have to end there. And because I don't want to do the rest of the work to the amp with the mids pot mod until, you know, it's really dialed in before that. So there's some work that needs to be done before we tackle that side. So all right, we're gonna end there. Thanks so much for watching. All right, so we're not done. I couldn't give it up, couldn't go to bed. I really just wanted to try and work on this a bit more because I was just so confused. So I ended up using a ton of naphtha, some Zippo lighter fluid, and really soaking in there, and it got a ton of the wax off, even with the isopropyl left. And then I heated it with a soldering iron again to really let it soak in there and clean out the areas. And then I hit the pot with a bunch of deoxit D5, and that seems to have fixed it. So the amp is on right now, and we can go through the range of the knob here. This was the reverb, and I think you guys were able to hear before it was making these incredibly loud pop noises, super, super loud. And now it's dead silent. So those are all totally fine, which is great. And we can check the voltage on the pot now, and we should be seeing basically nothing. So let's see if I can do this and show you guys. So nothing and nothing. So there you go. So that is fixed. And yeah, gnarly. I don't know if there's still any on the board. Maybe there's a little bit. Yeah, it still shows 0.1, which is crazy because there's nothing left here. I mean, it's just been doused in naphtha. But we were able to basically heat it out of the eyelets, whatever was there. You can see there's no volts. So no volts. So considering that solved, I just think getting everything out of the board is going to be basically impossible without a complete disassembly. But as long as the eyelets don't have any, we're good to go. So I'm really happy about that. And now I feel like I've earned some sleep. So we're going to end here and then come back to really just kind of go through it a little bit more, play through it, make sure everything's looking good, check the reverb, etc., etc. And then we'll dive into the mods. All right, thanks for watching. See ya.